My name is Elvin Slavic. I lead the the R&D office in Melbourne and part of the AppStudio development team. And my colleague here is
Erwin Sukianto. I'm the product engineer and product evangelist for AppStudio for ArcGIS in Redlands, California.
So even though our names are very confusing, I'm the slightly taller one, and my wife says that since I've been growing this beard, I look a little bit more like Hugh Jackman. So, clearly not. All right, in this session, we're going to be talking about some advanced topics in AppStudio. We've got quite a lot to cover. Hopefully we can get through all of it, but to get things started, this is basically some of the stuff we want to go through. So we're going to have a quick chat about the AppStudio 3.3 beta, which is out now. Erwin's got a couple of cool demos to talk about some of the new Bluetooth support. And then really what we want to do is show off a new Visual Studio Code. Who is a Visual Studio Code user here? Well, you're going to be able to use it with AppStudio as your IDE if you want to. So we'll show that off a little bit. And then what we'll do is we'll go and show off a bunch of different things that people may or may not were possible through the eyes of some of our sample apps, or actually our Esri Labs apps that we've gone and created, and show off some of the features that we've got there. And then at the end, we'll talk about mobile device management, which is one of the new capabilities in AppStudio as well. So without any further ado, I'll let Erwin talk a little bit about AppStudio 3.3.
All right. So just last week, we just released the 3.3 beta. The current release version is 3.2. What include in the 3.3? First of all, the 3.3 beta is available through our early adopter program. This slide will be shared, and you can click on the link. And also, there is a blog in AppStudio GeoNet that has the link and explain the rest of the functionality and releases that we have in the 3.3 beta. What you need to do to get the beta is to download the AppStudio desktop, meaning you need to uninstall the current version and install the 3.3 beta, and then download the player for iOS. There is a test flight link that you can click and get the 3.3 beta player, and then there is a link to download for the Android player. So 3 things that you need to have. 2 actually, depending on the platform of your mobile phone. What includes in the 3.3 beta is the underlying Xcode to version 10.1. Support for Android 64-bit. I just realized I have the same slide here. It also has the Qt framework, underlying framework, and Qt has been upgraded to 5.12.0, and it supports the MDM or EMM that Elvin's going to talk about later today. And last but not least, the support for the Visual Studio Code as an IDE. Not in this 3.3 beta, but we have upgraded a full redesign of the player in the last release. It has a really nice looking UI that you can take a look. It also includes the latest dark mode.
Just switch to yours for that one.
All right. So it includes the, so you can switch on and on from light and dark mode. And it has a lot of new design. If you've been using AppStudio since the early days, this is a long been waiting redesign to the AppStudio Player. So go ahead and check it out and let us know if you have any feedback. So Bluetooth and beacons. We have added support for connecting to devices through Bluetooth for connectivity. So we have a story that we call it the 3 Bs, not the Ball Brothers, but it's Bluetooth, Bluetooth LE, and beacons. In AppStudio 3.0, sometime last year, we added the support for the Bluetooth technology, and on the 3.1, we added the Bluetooth for Bluetooth low energy. And then on the last 3.2 and the 3.3 beta, we added support for the connecting to a beacon technology. If talking a little bit about the Bluetooth, It is the way to connect to GPS, external GPS devices, the GNSS, so that you can connect to devices such as Bad Elf, Garmin, so that you can connect to your phone and get a full accurate readings of your location. We have a blog in GeoNet that explain on how it works, and also Survey123 just released the support, full support out of the beta to connect with a lot of GPS receivers.
Yep, and I'll go into that a little bit more detail.
Right. So next. And these are the sample. It's called GNSS Info that you can try to see, take a look at the code that is available on how to connect to devices through Bluetooth connection. And Bluetooth LE. Bluetooth LE supported in the last release, 3.2. It is basically subset of the Bluetooth. As the name suggests, it is low energy. It ideal for transmitting smaller amount of data, but a lot of them. A lot of fitness devices such as Garmin, your Apple Watch, even a lot of other devices that's been using Bluetooth LE. So we have added support to that. We have a code sample in our AppStudio sample that connect to the Garmin Vivo. One of the things that we want to highlight is that the reason we are supporting Bluetooth LE, the main drive for this is because one of our one of our partner has been pushing GPS it. They're asking for the support, so that support for a device called plate meter. Plate meter is a device that will measure how tall the grass is, and it'll be used in New Zealand. So they've been asking for this. We added support for it, and then now they've been using it, and now they have the app to support selling these devices. So they can sell these devices and then have the app alongside with it, and people can connect to that device and then see the readings from the device.
So are people here using Bluetooth LE devices? Is that even of interest?
All right.
Well, we'll see.
How about beacons? Have any of you heard about the technology called beacons?
One guy.
Yeah, so it basically subset of the Bluetooth LE. The beacon communication that we support is the iBeacon communication. There is a blog about this, and then I'm going to demo using the Estimote beacon. So I'm going to open the website for the Estimote beacon before that. So if you can. So these beacons transmit data, frequent data to your phone, and then your phone can receive it, and it knows what ID it is receiving it from. A lot of people are using this beacon technology as part of the indoor navigation. It helps you know where the location of things inside the building. So we have added support for this. I have a cool demo using this beacon technology. So I have one beacon here with me, and I have one beacon that I've strategically placed behind you in that chair.
So just before we do that, you'll see that it's really good because that guy in that video was able to see where the shoes were. So if ever you've lost a shoe, you'll now be able to write an app to keep track of where your shoes are.
Or your socks.
I don't know whether, maybe. Yeah, it's really bad jokes, I know.
So I'm going to switch to my phone.
All right, so what you're actually seeing, we're talking about here, as Erwin explained, is the same sort of technology that's used for indoor positioning, so knowing where you are. The way that these beacons actually work, which maybe that video gave a little bit of a clue as, is by range finding the distance between yourself and the beacons. And there's a whole API and technology suite for doing that. So what have we got up on the screen here? So I've shared this sample in our AppStudio Player that you can search for. It's shared publicly. It's called Beacon Radar. You're welcome to, if you have the player right now, you're welcome to use it and try it. Or you can go back and see the source code for it. It's called Beacon Radar, so I'm going to start this. What I have here is just very simple. It lets you enter the UUID, the identifier for your beacons. You put it there and then you click Start.
Now it will tell you that whether you have received a signal from the beacon. In my case, I have received signal from a yellow beacon that has a distance of 0.70, half a meter from me, really close proximity. And I have another beacon in the back of the room that Elvin's gonna get. It's around 3 meters. And then what we're gonna show you, instead of me holding the phone going to the beacon because I'm connected, I'm gonna have Elvin walk to me slowly and show that the distance is getting smaller and smaller.
It's increasing.
Sometimes it gives you -1 result, but you have to filter that. So now it's 2 meter, 1.5 meter.
I don't think those measurements are right.
Say what?
They don't look right.
Yeah.
So this is emerging technology.
Right. That's why it isn't beta. But what we're trying to show you that we are supporting the iBeacon technology that you can try to use, and it's currently on a 3.3 beta player. And we have the source code and samples available so that you can try it out and see if we can implement something.
So the question is, could you augment this with augmented reality? Definitely, yes. I guess the difference between beacon technology and, say, GPS, and which most of us are familiar with, is that GPS gives you latitude and longitude coordinates. Beacons are about the distance from you to the beacon. So it requires a different way of thinking about how you would actually make them work in relation to where you are and actually triangulating your position relative to them. So the idea is that the beacon gives you a distance and a signal strength, and you kind of have to figure out, am I close to this or closer to that one, rather than actually giving you an exact coordinate.
Okay. So that was the demo of the beacon. The next thing I want to talk about is the support for Visual Studio Code in AppStudio. So as Elvin have mentioned, that we have added an extension for AppStudio in AppStudio Code. So what you need to do, it works on Windows, Linux, and Macs. Just like AppStudio. AppStudio works in all of this platform, AppStudio Desktop. You can install Visual Studio Code on each of these platforms and then download the extension for Visual Studio Code from the early adapter community. The AppStudio, currently we are using the Qt Creator, but this extension acts an alternative to the Qt Creator. So you still have to install the AppStudio Desktop, but then use the Visual Studio Code as the IDE to make changes to your source code. You can edit, upload, and run your AppStudio app, just like what you can do already in Qt Creator. And as I say, still use AppStudio Desktop to create new app, get samples, and do the rest of the things that you have been doing in the AppStudio Desktop.
How about we show them, Erwin? What do you reckon? Why don't we actually show them?
Yeah. I actually have another slide on the step, and then, oh, it's already there. So download the extension file, open this Visual Studio Code.
Oh, did we not have it up at all? Any of that stuff? Oh, sorry, that's our fault. All right.
That is why. Okay.
All right.
So we're going to go back, and so this is the slide that I was showing you that is available on all of the platform.
Is it possible to debug Visual Studio Code's with Visual Studio Code? Semi. So it doesn't have a full debugger in it, but what we're doing is integrating the console output from the app so that you can actually directly jump to the line of code when you're inside Visual Studio Code. But it's not a full debugging environment, because you actually have to have a full development environment to get a debugger.
So this is a slide that shows you where to download it. And just a quick step on how to download it. You need to download the extension file. Open the Visual Studio Code, and then on the extension side, upload that file. So I'm going to show you a quick demo on the AppStudio code. I'm going to end the show. So what I have here is the AppStudio code, and then the extension that we have here is the AppStudio for ArcGIS. So after you uploaded that file, you would see that you have this extension installed in your AppStudio code. And then now, on my file editor, I have, if you have the AppStudio folder uploaded here with the appinfo.json, it actually reads that files to know that it is an AppStudio project. And on the bottom here, it says AppStudio project. Here are the actions that you can do. You can click on the app run, app make, app upload, and app setting. So for example, I can run it. So all of these symbols have all the same action in this right-click menu. I'm going to run this, and then it will run this quick capture app. You can go into the setting. You can go to the app setting and change the setting of this app. And then you can trigger Cloud Make and Cloud Upload from here.
So that's a very quick demo.
Right.
We've been starting to use Visual Studio Code more in place of Qt Creator. For those of you that use Visual Studio Code, it's great because there's lots of extensions for different file types. It's a great environment. So what we're trying to do is find what's the best way that we can tightly integrate it into. So we've included code completion as part of the extension, syntax highlighting, integration with the console output. You can see the tools are shown there in the side window. You can also have multiple projects open at the same time, so it will actually show you each one of those. And it also integrates with the online help, so that when you actually click help on something, it actually jumps into the online help on it. So it's still in beta. We've only just released it last week outside of our internal development to get some feedback on it. So please, if you can, and you're interested, jump into the early adopter community, download it, try it out, and give us some feedback on it and what you'd like to see out of it.
Yeah. As you can see here, it has the syntax highlighting with coloring, and then syntax completion as I type the properties of rectangle, and it knows that there's a radius property, and then it auto-completes. Just like what we have in Qt Creator.
Okay. All right, well, if we jump back to my machine over here, what we're going to do now is actually take you through some of our template apps and some of the apps that some of you are already using, and look at a couple of features in each, and see how they're actually used, what they're actually using out of AppStudio to achieve that functionality. So anybody in here a Survey123 user at all? Okay, a few people. For those of you that aren't, you should be Survey123 users. I don't know what's wrong with you. So the main feature I want to concentrate on here, this is not a Survey123 demo, rather I want to actually show you the new GNSS support that makes use of the functionality that Erwin was talking about a little bit earlier. And jump in and actually show you just a little bit of code, because we're at a developer summit, and actually give you some pointers as to how this actually works. So the functionality we're talking about, and this is a screenshot here, and I'll run it in a sec, allows you to connect to external GPS receivers inside Survey123, and in fact, hopefully, most of the rest of our apps when we actually port this functionality to them as well. And it's also functionality you can very easily bring into your own applications. There are a couple of concepts that we need to kind of introduce to kind of make it a little bit clearer how this actually works. So for those of you that may be interested, and I put this in just as an FYI, we actually have a session tomorrow afternoon that talks much more about extending Survey123. And the reason that's of interest is you can actually use AppStudio now to actually build new functionality for Survey without actually having to modify the Survey123 code. So it's a new add-in extensibility model. Not covering that here today, but I thought I'd put a pointer in that for tomorrow. So we'll come back to that one in a minute. So what I'm going to do here is just jump to my machine, and I'm inside the Qt Creator IDE, and I've got the Survey123 source code open. So what I'm going to do is run a version of Survey123 on my machine, and what I've got in my hot little hand here, hopefully it's coming up there, yep, is, because I'm using a Mac, and it was the easiest way to demonstrate here, is I've got a USB GPS receiver. here. So although this functionality we were talking about earlier was about Bluetooth, which is what you would typically hook up an external GPS on a mobile device, it's not limited to Bluetooth. It actually supports USB, network connections, and Bluetooth all in the one design. So I'm going to plug this into my USB here. And I'm going into the Survey 123 settings. And this is where you can actually go and configure a new external receiver. So what I'm doing is going to add one. And on Macs, when you plug in GPSs into the USB, they get funky names. The one that we're actually interested in is this modem 14, whatever number that is. That's the number that my Mac assigned to this USB port when this GPS was plugged in. So if I add that as a provider, Survey 123 has basically made a connection to that receiver. And if I click on the icon up here, I can see no data is coming, no coordinates are coming through because I'm actually not outside. So this actually isn't receiving a position. If I was, this sky plot for the GPS would actually be showing me signal strengths and a sky plot of where all the GPSs are. That's not working in here either because we're actually indoors. But the thing that is working is the last screen, which is the debug screen. And what that's doing is giving me a live output of the data that's coming in via my USB port here. So that's actually how it's implemented from the user's perspective in the code, in the app. What I want to do now is just spend a couple of minutes and have a look at some of the components that are actually achieving this functionality. So the thing to remember earlier on when we were looking at this was in this page, when we added a provider, you can see here that there was this discover thing, and it let me discover devices, including ones that are connected via USB or Bluetooth or other types of things. So if you kind of keep that in mind for a sec. Now let's quit out of here. What I'm doing is now jumping into the Survey 123 code, and this is kind of the module that's actually taking care of the behind the scenes logic for what you actually saw. Not the UI, but the actual connectivity side. So what you find in the app framework is this thing called a device discovery agent. And this is basically a component that can discover Bluetooth devices and things that are connected physically to your hardware if it supports it. The device discovery agent is dynamic, so as soon as you plug a device in or a new Bluetooth device comes in range, it will actually continue polling and send you a signal that that device is visible. Now here, what I'm doing is filtering out certain devices based on the user's UI settings. So if the user said, I only want to see Bluetooth things, we filter out the things that are not Bluetooth. If they only wanted to see USB connected devices, we would filter those out. So this is logic that you build in your code to decide out of all of the devices that the device discovery agent is discovering, what am I actually really interested in? Does that make sense? So that basically makes it very easy for your app to discover what equipment is around you and can be connected to without you having to worry about how to do different types of connections on different types of hardware. So it basically abstracts all that stuff underneath to make it easy for you to make that connection. So having done that, the next things that we're interested in is GPS receivers, in this particular case, put out their data in a protocol called NMEA. So people here familiar with NMEA protocol? Yep, a few of them. So we have a component in the app framework that is designed to parse NMEA data coming from some source and automatically do the checksums and the parsing of it and break it up into a much more usable format so that you don't need to. So that's called the NMEA source component. And without getting into too much of the other code, essentially what the app's doing is discovering a device and hooking it to this NMEA source. And the data that's coming from the device is then being parsed by this NMEA source. The other components that we're interested in is once we've got the NMEA source, that isn't actually still a GPS. That's simply data that's coming in from some device and being processed and taken care of for us. What we then need to do is actually take that data and tell our position source to interpret that as positions coming from a GPS receiver. So for those of you that have written code before with AppStudio, you may be familiar with the position source component. Anyone familiar with the position source component? Great. So this is a drop-in replacement for the existing position source component. So the Qt framework provides us with a position source component that's designed to talk to the internal location sensor on every platform. This one does that, plus allows us to talk to external devices. So what we do is we actually hook up our NMEA source, coming from parsed NMEA source from the device, to our AppStudio version of the position source, and it will take the NMEA sentences and go and pull them apart and suck out all of the bits that it's interested in using. From there on, you can use it just like a position source from the Qt framework. The additional functionality that you get out of it is you get all of the metadata that's coming in with that position. So you get things like the PDOP, all sorts of other bits of information about accuracy, and any other metadata that's available on that location as it's coming in becomes available for every single position. The other thing that we get out of it is we can get out of it the satellite information. So just like we can take the NMEA source and hook it to our position source, we can hook it to our satellite info source. And the satellite info component is designed to parse all of the satellite-specific information so that we can do things like display that sky plot that you saw before. It gives us the azimuth and the elevation and the satellite number for every satellite. Now, some of it we may choose to store and some of it we may choose to use for UI. So this series of components makes it really, really easy to use high-precision GPS receivers on any platform, regardless of whether the devices are connected via USB, Bluetooth, or a network connection. Does that make sense? So the other thing that you can do there is that a lot of devices use the NMEA protocol to provide their data, but not necessarily location data. So for example, a lot of rangefinders put out their information as NMEA protocol strings. You can actually use the exact same components to receive and parse and process data coming from other instrumentation. And the process is identical. The only difference is that instead of then hooking those components to the position source and the satellite info, you simply take the data straight out of the NMEA source and you get the values out of the relevant fields that you're interested in. So hopefully that's got some use for some people.
And this source code not only available in Survey 123 source code, but also in the GNSS Info sample.
Yeah. So this technique of working with GNSS receivers is actually being put into all of our applications now.
Yeah.
So Survey 123 has it out of the box now in the release version, and now we're actually adding the same functionality to all of our applications that have support for location sensors. So I'll jump back to my slides here. So the next app I want to have a quick look at here, and if we jump to my phone. So how many of you have used our Esri Labs apps that we put out there? One guy, you're into everything that we do. It's great. So for those of you who don't realise, a lot of our prototype work and some of our development work, we first released through Esri Labs. Now, Esri Labs is a way where we can release some of our development into the user community space before it actually becomes a product, or it maybe never becomes a product. So these can actually be found in the app stores under the Esri Labs branding. So what I've got up there is some of the Esri Labs apps that we've gone and created. And I want to actually explore a few of them and kind of look at some of the features that they've got in them and see what that brings for us. So the first one that I want to have a look at is My USNG. Now, has anyone in this room ever used My USNG? Nobody. God, what is wrong with this planet? So My USNG is a very simple app that was created in response to to help first responders and the community be able to communicate their location very easily. So USNG is a US National Grid coordinate format system. It's a way of being able to show your coordinates in a text format that can easily be conveyed between different organisations, a lot of which are first responders, police, fire, and so forth. So this app is designed simply to start up on your machine and show you your coordinates in USNG format. So where I'm currently standing, according to the location sensor on my iOS device here, our USNG location is 11S-NT-4266-4302. And if someone was looking for me and they understood USNG coordinates, this is a coordinate that I could give them and they could actually send and help me and get me off this stage. But this format is used widely in the first responder community and is designed so that not only can it be presented in apps, you'll actually find in a lot of national parks and things blue signs that have a USNG coordinate. The whole idea of that is that if you're lost, that you can read those coordinates off to someone maybe over the phone or some other mechanism they find you. Now, we're not here to promote my USNG or this coordinate system. What I wanted to do is just show a couple of features this app has and see how easily you can do the same thing in your own apps. So one of the things this app does is it's got a little share button up here. So it's a share button that you've seen in lots of other applications. I click this button and it basically lets me take my current USNG coordinates and share it through the standard share sheet mechanism that's available on my platform. So on iOS, this is a very familiar looking thing. If I run the same app on Android, I get the Android experience. If I run it on my Mac, I get the Mac experience. So this is basically every one of our operating systems that we use commonly has a similar kind of thing for this, but it looks different on every platform. But the idea is to somehow be able to share out information from your app to another app. So that's one thing. The other thing that this app actually lets you do is have a very simple map display. So we've seen maps in all sorts of apps. The thing that it does that's kind of interesting is that it's got a toolbar at the top that lets you put in your coordinates or an address and search for them. So if I type in something like -37, 144, that's somewhere near where I come from in Australia. Now you think, oh yeah, big deal. He went and typed some stuff into the coordinate box and it knew where he was. The thing that's interesting about that one is that uses a function in AppStudio that automatically can parse any type of coordinates that you give them and figure out what they are. So you can put in lats and longs, or you can put longs and lats, or USNG coordinates, or UTM coordinates, or anything, and it will figure out what coordinates they are and tell you what they are so that you don't have to worry about parsing them. So if we jump back out, these are some of the features that the My USNG app uses out of AppStudio. I've highlighted a couple of them, and what I want to do now is just jump into the code and just have a look at how complex, or hopefully how simple, it was to do those two things that we just saw. So let's go back to Visual Studio, and I'll make my USNG my main app, and I'm just going to run it one time on here. Because remember I hit the share button on my iOS device and I got that pop-up thing? When I hit the share button on the Mac, I get the Mac sharing experience. So that's this. I must be on my second screen. Hang on. Is that better? Can we see it? Yep. Okay, so I hit the share button in my USNG and I got the Mac sharing experience. Okay, that's just so that we can see it working. So what I want to do now is have a look at how did the sharing thing actually work? Like how much code did it take to make it go and do that stuff? So if you can imagine that the app basically takes your coordinates and generates a string that contains a string that I want to share to another application. That string is that coordinate that we saw on the screen. This is the line of code that makes that pop-up occur. That's it. So the app framework in AppStudio basically has a clipboard component, and on that it has a share method. That share method hooks into the operating system's sharing API to provide you with a UI that's native to that operating system for sharing text. So this function, called share, is the function that gets called when I hit the share button. The next thing it does is get some share text. That share text is my app generating a piece of text that I want to share to any other application that can use it. All that happens then is that I take that text and I share it. that will pop up the UI, and then from there on, it's whatever application the user uses. It will send it as an email, send it as a message, and so on. Pretty simple stuff. Pretty easy. The other thing that we were looking at before was that I typed in some coordinates into an input box, and it somehow determined that they were coordinates. That's done. I've lost my spot, so I'm going to look for the code. Far out, my eyes are going. So, putting aside all of how the UI actually works and all that sort of stuff, the piece of magic that actually did that is this coordinate.parse. So most of you understand JSON.parse in JavaScript, which basically give it a string and it basically turns it into a JSON object. The idea behind this is that you give it a string and it turns it into a coordinate object. So you give it a piece of text and it will figure out if it has a coordinate in it or not. If it's not a coordinate, it's up to you to decide what you do next with that piece of string. If it is a coordinate, then it will break down that coordinate into a JSON object and return it to you and give you the Latin long and a breakdown of all these different pieces of what that coordinate goes and does. So it's designed to be conceptually similar to JSON.parse, but for parsing strings that contain coordinates in them. So it's a very flexible thing. The options that I provided there are the options of what coordinate systems do I want it to recognize. Do I want it to recognize everything, or do I only want it to recognize specific coordinate systems? So it makes it very easy to work with parsing text that contains coordinates. There is a flip object, or flip side object for that, which basically is like the stringify version. So you can actually give it a coordinate and turn it into any other coordinate format, and it will give you back a stringified version of that coordinate, usually for display purposes. So hopefully that's useful to some of you. Okay, so our next example, wow, what am I looking at here? Is quick capture. Have people seen or heard about quick capture? No. Okay. So you've heard that we promote our apps as map-centric. Yep. Collector, things like that. You've heard us promoting our apps as form-centric. Servo 1, 2, 3. Well, this is the third installment of centric apps. It's button-centric. So what does that actually really mean? Actually, before we flip over, I'll just use my thing here. So Quick Capture was released as an Esri Labs app last year as a button-centric data capture application. And it's basically for people that need to capture data very quickly by simply pushing buttons on the screen. They don't have time to look at a map, they don't want to digitize in a map, they don't want to fill in a form, they just want to push a button and collect data. So that may be that I'm walking along and I'm collecting pothole locations as I'm driving along the road, or I may be collecting guardrail locations as we're driving, or we may be flying in a helicopter and we don't have time for input, we just need to hit a button as we're actually going and collecting that data. The UI for this is buttons. And you can configure the app through feature services to represent different types of features that you want to collect when that button's pushed. So I might just show you the app. Here we go. So on my machine, I'm going to show you the prototype version, the one that's in Esri Labs of the Quick Capture app. And if you're interested in knowing more about this app, it's actually now being productized. So in tomorrow's Apps Road Ahead session, there's actually a section actually talking about Quick Capture specifically. But we're here actually more interested in the developer side of things. So let's have a look at how it looks from a developer perspective. So basically when you run the app, you choose who you are. There's a project list, basically of different types of data capture projects that I want to go and capture. In this case, it may be guardrails. And I have buttons representing different features. So when I push that button, you can see it flashes when I collect it. That collects the data. I don't need to see a map. I'm driving along. It uses my location sensor, and it simply creates a feature at my current location based on whatever attributes that button represents. Now, in this app, we can go and collect points, lines, polygons, and all sorts of different things. So my app may actually be designed for capturing a track. So when I click this button on, that starts flashing, telling me I'm capturing a track, and I can then keep riding my bike or driving my car or whatever I'm doing. I don't have to look at the screen. I push a different button and it starts capturing a different feature as I'm driving along. So that's quick capture. What we want to have a quick look at is, if we switch back to my machine, is what's quick capture doing that may be of interest to us as developers. So it's using a whole bunch of features out of the app framework, including offline storage, storing stuff into a SQLite database. We all know you can use SQLite databases in AppStudio. I don't need to tell you any of that sort of stuff. What you may not know much about is user-defined functions in SQLite databases. So we'll have a bit of a look at what that means. Other stuff that it can do is it can run in background. So I can put my device to sleep, put it in my pocket, and it will keep working in background. So I can actually use the location sensor and the SQLite database and have the app continue collecting data in background. Now, I actually don't need to show you any code because actually quick AppStudio apps can just do that out of the box. You don't actually have to do anything special. The app actually uses the text-to-speech API, and it actually uses that same coordinate.parse and formatting component I talked about before. The thing that I do want to spend a little bit of time looking at there is just show you some of the features of the SQLite database that you may not be aware of. So who here uses SQLite in their applications? I knew you were going to be doing it. Anybody else? All right. So let's go and have a look at the component in quick capture that's using the SQLite database. And now this is coming out of the AppStudio app framework. And what it is it's a component that makes it very easy to open and use a database, SQLite database, on any device. What I have here is this thing called a scalar function. So when you run a select statement, most of you are familiar doing a select something, and you can use SQL functions inside a select statement. Now, if you've used SQL Server, you know that you can use things like .NET and CLR to plug in .NET functions into SQL Server. But most of you probably have never thought that that's possible with SQLite, in that you can actually plug in your own functions into the SQLite engine that can execute inside the SQLite engine and be called as part of a select or any other SQL statement. These are through these things called scalar functions. So they're functions that you declare when you create a database that become available in the engine. So what I'm doing here is declaring a function in my QML JavaScript code that will execute inside the SQLite database engine when it executes queries. Now, you think, I don't know what he's talking about or how useful that would be. This is a very simple example to solve a common problem that often happens for people, which is, in this case, I'm using the SQLite database to store coordinates as they're being streamed in and in quick capture in the capturing. As part of that capture process, we may be taking photos. Now, those photos are not being stored in the database, they're just being stored as files. And the file name of the photo is actually stored in the database. It's a pretty common technique that's used in lots of applications. What I did want to do was make it simpler, or simplify my code, so that when I delete all of the rows out of the database that are associated with files, I'd like the files to automatically get deleted as well. So I want to maintain the referential integrity between my persisted files and my database rows. Now, it's pretty common logic, and most of the time if you were implementing this, you would do something like, well, when I delete a row, before I delete them, I'll query all the list of file names, then I'll keep those, I'll delete the row, then I'll go through and delete every file name, right? Pretty standard type of operation. What I wanted to do was have it so that I have a trigger that when a row deletes my database, that everything associated with it deletes as well, including the files. But I didn't want to write a lot of code to do this. So this function that I've declared here is a function that simply deletes the file name that's passed in as a parameter. So there's a JavaScript function here that basically takes the file name in as a parameter and deletes it. Right? Pretty simple. The rest of this stuff up here is declaring what's the name of that function from the SQL side. So what name do I want to give this function that can be called from my SQL statements? And what type of parameters can it take? So it takes one string as a function, and the function's not deterministic. So everyone's a developer geek here. We know the difference between deterministic and non-deterministic functions. Well, basically it means if it's not deterministic, it doesn't return the same value every time you run it. It's a simple way of looking at it. So, not important to our thing. Essentially, what I've done is declared a function into my SQLite database that will automatically delete a file if it's given a file name. So how have I actually gone and used it? So if I look down here, when I created my database, and I know all of you are SQL junkies and all that sort of stuff out there, so you'd be going, oh yeah, I get what he's talking about. I created a number of tables, and there's some referential constraints going on between these different tables. You can see here I have a table of features and some attachments. These two tables are related to each other, including the points that are associated with them. I then created a trigger, basically that says delete attachments. So every time a row gets deleted from my attachments table, then also call the delete attachment file function, which I declared into my database. So what that means is that when I do a delete, SQL delete on my database, it's automatically going to trigger a trigger a delete action, which is going to cause my stored procedure there to also delete all of the files associated with that table. So basically it's one line of SQL code and about 4 lines of JavaScript code to achieve what otherwise would have taken me lots of functions and lots of code, and usually you get it wrong and the files get left over and you've got to maintain all this logic. So this builds on the power of the referential integrity of the database, but I'm using it as part of my app logic. So what it allows me to do is actually blend app logic into my database engine, which can greatly simplify complex stuff, but it also gives you a whole world of new capabilities that you may not thought were possible before. Would anyone even use this? I'll give you some time to absorb, maybe how this stuff can get used. All right. So that we don't run out of time here, let's go back to our slides here. A couple of other apps that are out there, so let me just switch across and then we'll come back to the slides. Is another app that we've got is called Trick2 There. So Trick2 There is designed to be an app for as the bird flies or as the crow flies navigation. So you've got Navigator and things like that give you routed navigation. This one, and I'll use the same coordinates I used before, which will put me somewhere not very close to here. We don't have a position in here. Oh, there we go. So this is basically saying, you saw the camera pop up for a minute, but our location's coming in and out. It basically said if I walk 12,000 kilometres in approximately that direction in a straight line, I'm going to end up at those coordinates that I just entered. So it's basically a straight line navigation. The camera will only appear when we've actually got a valid coordinate. There you go, it's coming in and out, so our coordinates our location's coming in and out. So it's basically saying 12,894 kilometres in that direction is where I need to head. Now this is basically designed so that it uses the compass internally and gives me a direction indicator of which direction I need to walk. Now it doesn't work very well indoors like this. Maybe we could make it work with the beacons. But it's designed to be used outside so that I can basically have it, as I lift my device up, the camera appears. If I push it down, then I actually get a compass bearing. So it's automatically detecting which orientation my device is in and showing me either a camera view or a compass view. Again, it doesn't work very well indoors. So the reason I wanted to point this one out, if we just jump back to my slides here, and I do actually have a screenshot of it working. So this is basically the two views that the app actually has. If I was holding it up, I would have my camera view and it would be showing me sort of this perspective view compass indicator. Or if I lay my camera down, device down flat, I get a compass, more like a traditional compass. So I won't spend much time actually looking at the code on this one. I guess what I wanted to point out was this app makes use of quite a few different things. The location sensor, how to use the compass, how to detect the tilt and roll and orientation of the device to tell whether the user's holding it up or holding it flat. It's using the camera, it's also using the GNSS library for the position, and it also allows you to link this app to other apps via a URL. So I kind of wanted to point out what are some of the features that you would find if you looked at the code. So you would download the app, play with it and go, well, how do they actually do it? This is an app that actually kind of explores some of these features and shows you how they work in a functional application. So the very last one I wanted to kind of show before our last topic, and again I will just do a very quick demo on my device. Have any of you seen Geo? No? Okay, let's try that one out. So Geo is an augmented reality app that basically I can pan around and see where features are that are close to my location. So this is downloading data from a point feature service, your point feature service, and simply showing me, as I zoom around, where those locations are. And I can then click on them, and it gives me more detail. I can have photos attached. So this is data coming straight out of a feature service, shown in an augmented reality view. And you can see the map rotating down the bottom here as my compass is moving around. And if I click on that, you can see as I'm zooming around, that's the direction the compass is looking at. If I zoom out, that's where those features are. So that's Geo. Now that's actually been in Esri Labs for probably over a year now. What you may not have realised is that the source code for it, like all of these other apps that I've just gone and shown you, is available for you to actually go and use as is or modify. In the case of Geo, it makes use of the location sensor, the compass, the same sensors that we saw before, and the camera. It's just got algorithms in there to project your feature service into a 3D or pseudo 3D space. So all of these apps that I've just gone and shown are available to you through GitHub or as templates through AppStudio.
Enterprise template.
Yes. All of these apps that I just showed are downloadable from the App Store. You can get on there and you can try it straight away. Now, if you go to the repos, like for example, Geo has a repo there, there's instructions of how to load your own feature services in there and load your own data. So you can use all of these apps out of the box to get familiar with how they work, and then you can jump into the code to see how those features were actually implemented. Okay. So our last topic for the day, did any of you go to the AppStudio Apps for Enterprise session just a few minutes ago that Satya presented? Yep, a few of you were there. So I'm just going to recap very quickly some of the, I guess, the developer side stuff of how we're now supporting mobile device management systems, MDMs. So the reasons organisations are using MDMs is varied. It's from being able to manage security better. Maybe you're in an organisation where people are bringing their own devices and you want to be able to control security and what apps are installed. Simplify app deployment across massive installations. We're working on projects like census projects where organisations are looking to deploy applications like AppStudio to over 100,000 mobile devices. So installing an app on 100,000 systems takes a pretty long time. If you have to fire up every one of them, go to the App Store, go install, you'd be there for a pretty long time. So things like MDMs obviously can greatly simplify the deployment process. They can also simplify pre-configuration of apps, having a fixed portal URL and then maybe other app configuration stuff. So this is functionality that we're actually building into our apps, like the App Player, Survey123 will get it, and most of our, in fact, all of our apps will end up ultimately having mobile device management support. The topic I wanted to talk about here is how does it actually work behind the scenes? What do you need to do to make your applications MDM compatible or MDM ready? So to support this, what we've done is adopted, or we're following a scheme called AppConfig. So AppConfig is a specification, if you like, that the manufacturers of software for managing mobile deployment systems have all agreed upon that they will all support. So their systems may work differently behind the scenes, but they've all agreed that from a specification point of view, that applications can configure themselves using a common standard way. And this is called AppConfig. Now, AppConfig is quite a big specification. The bit that we're interested in initially is how we can pre-configure parameters down to apps. And this is done through the AppConfig configuration for apps specification. Now, what that ultimately comes down to, it's an XML schema specification. So it's a well-defined XML schema that you can basically design your parameters and your configuration so that any MDM that supports AppConfig knows how to interpret that schema and push those parameters down to the apps on the devices through the mechanism that that system uses. So they don't all have to work the same way, but they all need to support the same specification. Does that make sense? So that's the actual standard that we're adopting. From your code point of view, it actually ends up being pretty simple. So we've got a new import called management, and inside it, it's got a managed app configuration. So this is a component that you can use in your application to basically retrieve configuration parameters that can be sent down to the app. So it's basically like a settings file. You've got to think of it like a settings file, but it's not a settings file managed in the app, it's a settings file managed by the mobile device management system. Now, it can have defaults in it that you can read out of it, so that if you're not running on an MDM, you've just got default values. But if you are running on an MDM, then the MDM can push new values into that same settings configuration. So from your app code, you can get a live signal when that configuration changes. So the moment that the system administrator has pushed a new configuration setting, you get a signal in your app, if it's running, that a parameter has changed in that device's configuration, and your app can react to it. And that comes down to basically watching two signals in this thing. The on settings changed and on policy defaults changed. So have the defaults for my application changed, or have the settings, the live settings changed? And basically I get one of these two events, then my application logic simply pulls out the values of interest and propagates them throughout the app in whatever way makes sense for the application. So supporting an MDM becomes actually quite straightforward from your application point of view. It's the app framework that takes care of how the app config and the app, then the MDM and all that signaling works to basically deliver those signals to your app. Does anyone here want to deploy their apps in an MDM? There's a lady down the back. I thought you would at least. Surely. So that basically, the last point I wanted to point out is if you are into this, we have a blog and a sample app that actually shows this component in use, so that if you've got an MDM in your organization or you're trialing MDMs and you're interested in experimenting with this, we have a sample app that basically you can deploy in your organization and try this functionality out and see how it might fit. So we've covered a whole bunch of different topics. I guess the difficult part for us is actually picking what sort of advanced topics might be of interest to the audience. Hopefully, that's given you an idea or some inspiration to maybe have a look at some of our labs apps, or maybe look at other things in the app framework if you're already an app developer that you may not have realized is there for you. Or some of the new features that have come out that maybe you wanted to bone up on. So with that, we've got a couple of minutes of questions. Not one question. One question. Thank you.
Does 3.3 non-beta, when is that approximate?
When is 3.3 expected to ship? We're expecting to ship at the end of April if everything sticks to schedule. Yep.
By the end of April.
By the end of April, yes.
Will that have, and that'll have the Visual Studio Code?
So the Visual Studio Code you can work with straight away.
With 3.3 beta or?
So the Visual Studio Code extension is something that you can install without 3.3. So you can actually use the Visual Studio Code with your current version of, so that it's actually not linked to AppStudio 3.3. We just happen to make it available at the same time. So you can work with the Visual Studio Code extension right now if you want. Is it the same time the new runtime comes out? Yes. Yes, so the new runtime will be part of the AppStudio 3.3. That's actually one of the reasons it's shipping in late April. All right. Thank you very much, everyone.
Right on time. Thank you.
Thanks for attending.